is Antonio Fortunato and I am Deputy Head of Crew Operations for the European Astronaut Center in Cologne. The topic of this lesson is the International Space Station. As a vehicle, we will discuss its modules, its main capabilities, and to a lesser extent, its operations. Now, one very important element that is located outside the ISS is the Space Station Robotic Manipulator, or Canadarm2. This is an incredibly important piece of equipment because it performs and it allows us to perform functions that would be otherwise impossible. One important function is really to move equipment to different parts of the station. Here you see in the picture the SS RMS unloading cargo from the trunk of the HTV and preparing it to move it somewhere else on the ISS. The space station is also used, for instance, to move replacement parts. I mentioned before the thermal control system. The ammonia in the external thermal control system is pumped around by some pump modules. And pump modules are pieces of equipment that can fail, and they did fail in the past. Astronauts had to be sent in a spacewalk to perform repairs, and the robotic arm was used to take the spare pump modules from storage, take them to the location where the repair had to be implemented, and then of course they were used to take the spent pump module, the broken one, and be put in storage somewhere else. The space station robotic arm is also extremely important because it is used for track and capture of some visiting vehicles. We have seen before that at the moment the ISS can be visited by Soyuz, Progress, Dragon, Cygnus, and HTV. Now, the Soyuz and Progress are the only vehicle capable of autonomous rendezvous and docking. All the other vehicles only get to the proximity of the ISS, and that's where they are grappled by the robotic arm and then taken in. So not having a robotic arm or not having a working robotic arm would mean that we would lose the vast majority of our capability to receive cargo on the ISS. Also, as we've seen before, for the case of the solar array repair, the robotic arm is an essential element for EVA support. And not just for moving equipment back and forth, but also for moving astronauts. Sometimes there are locations on the outside of the station that are not easily accessed or are impossible to be accessed just by moving along the structure of the ISS. And the robotic arm is instrumental in allowing the astronauts to reach all parts of the outside of the space station where work needs to be done. All right, those are the most important elements. Those are really the highlights in terms of what's outside the station. Now, what are the pressurized elements? What are the different modules that compose the stack of the ISS? Well, what I really would like to do is to take a tour of the ISS in a fashion similar to what an astronaut just docking to the ISS would do. And we will imagine that we will be docking with our Soyuz to the docking compartment 1. It is the module that you see here circled in the diagram, and we will move from there and visit each and every module of the ISS. Now, docking compartment 1, also known as Pierce, is the module that you see here in picture. Is a relatively small module, and it belongs to the so-called Russian orbital segment. The docking compartment 1 fulfills two basic functions. First and foremost, it provides a docking port for both Progress and Soyuz, and it provides also an airlock for spacewalks that employ the Russian Orlan spacesuit. Basically, the hatch of the docking compartment 1 can be closed, the air removed, and astronauts can go out of a second hatch and perform their EVA. Now, if we move out of docking compartment 1, we enter the service module. And the service module is really the heart of the Russian segment. It is one of the earliest modules that was flown to space, and if it looks like the base block of the Mir space station, it's because it is very similar to the base block of the Mir space station. As a matter of fact, the service module, or Zvezda as it is also known, was supposed to be the base block of the Mir 2 space station. This is what the SM looks like from the outside, and this is what it looks like from the inside. There is really a lot going on in the service module. The service module contains lots of systems, lots of computers, lots of equipment responsible, for instance, for the removal of carbon dioxide and the production of oxygen. But the SM is also very important in terms of what it provides to the astronauts. In the SM, there are exercise equipment. You see here in the picture the Russian treadmill, the BD-2, as it is known. There are also 2 sleeping compartments. They are normally called cayutas. There is a toilet, and there is a galley, there is a dining table that astronauts and cosmonauts can use to have their meals. By the way, the blue and red containers that you see in the background are food containers, and the different color code is to distinguish between Russian provided food and the USOS provided food. Now, also attached to the service module opposite to the docking compartment 1 is the MiniResearch Module 2, or MRM2, or MIM2, or docking compartment 2, or POISC. The MRM2 is basically a photocopy of docking compartment 1. It is exactly the same in terms of layout and equipment. It provides the ISS with an additional docking port for both Soyuz and Progress, and in theory it could be used also as an airlock for Orlan-based EVAs. At the moment, however, it is not used for this purpose, and it is mostly employed as a stowage location. Now, moving out of the SM, we would enter the FGB, or Functional Cargo Block, or Zarya. The FGB has been the very first module of the ISS. It was launched in 1998, and it basically worked as the original initial building block of the space station. What is very interesting of the FGB from an historical perspective is that it used to be part of the cargo system for the military ALMA stations in the 70s. The design is really derived from that kind of program. Now, the FGB had a very important function at the beginning of the ISS program. It was generating power with its solar arrays. It contained a number of important pieces of equipment, but right now, 20 years down the line, it is almost only used as an interconnecting module. It is used to contain cargo, and even its solar arrays are not really used anymore to produce power. They are partially folded back. Attached to the FGB, we have the MRM1 or MiniResearch Module 1 or RASVIET. It is a little bit counterintuitive because we have MRM1 and MRM2, but the MRM1 and the MRM2, they really do not look alike, while the MRM2 is really the same as the docking compartment one. It can be a little confusing, but bear with me. The MiniResearch Module 1 is actually the only module on the Russian side of the space station that was not flown on a Russian rocket. It was actually brought to space in the cargo bay of the space shuttle, and you see here in the picture the MRM1 being installed by the robotic arm. The MRM1, again, it can be used to host equipment for research and some of the systems, but it also provides additional storage space, and it also provides an additional docking port for Soyuz and Progress. Now, if we look at the ISS diagram, it is really interesting to see that there is a certain redundancy when it comes to the station docking ports. Soyuz and Progress can dock to MRM1, MRM2, docking compartment 1, and the service module. This gives us a good redundancy, it gives us a good buffer in case of problems. Consider that when we have a full crew complement of 6 people, there must be always 2 Soyuz docked to the ISS to serve as rescue vehicles in case there is any issue, and there is always at least 1 Progress docked. So we have some redundancy, but it is really not that much. And Soyuz and Progress can only dock on the Russian side. They have no docking port in the so-called US orbital segment, which is what we will see in a moment. Now, if we move forward, we leave the Russian segment and we enter Node 1 or Unity, the first module of the US orbital segment. As the name suggests, Node 1 is actually an interconnecting node. It provides berthing locations for additional modules. There are obviously 2 of them, forward and aft, and there are additional 4 all around the module. Now, Node 1 has been used in different ways over the course of the ISS history. At the very beginning, this was one of the very early modules, and at the very beginning it was used, for instance, also to host exercise equipment. At the moment, it's really an interconnecting node. It provides storage location, and it provides the second galley of the ISS. We have seen that there is 1 galley, 1 dining table in the service module. The second dining table is here in Node 1. And here you see a nice picture from 2009. You have crew members from the permanent ISS crew sharing a meal with the visiting crew from the space shuttle that was docked at that point in time to the ISS. It is very important, this social component of having meals together. The space station is a big vehicle, there is a lot going on every day, and it might happen that 2 astronauts belonging to the same crew might not see each other during the day because they are tending to their own activities. And over a 6-month mission, over a long duration mission, it is very important that at least once during the day the entire crew gathers together for a common meal, and this common meal is either taken in Node 1 at the US galley, or it is taken in the service module in the Russian segment.